Right. So we're diving deep today, and I'm excited about this one.
Yeah, me too.
So this is a deep dive right into some really fascinating material that you sent our way. Excerpts from Daniel Kahneman's Thinking Fast and Slow.
Yeah.
We've got his reflections on like decades of work with Amos Tversky and just summaries of their many revealing experiments, I guess you could say.
Yeah, groundbreaking.
And some fundamental discoveries about like the core of how we think.
That's it. We're trying to, the goal here is to kind of give you a peek behind the curtain, of your own mind when you're making decisions, when you're forming judgments. We're going to try to uncover those automatic mental shortcuts and the biases that are constantly at work, shaping those choices, often without you even knowing it.
Yeah.
And hopefully giving you a much clearer lens to then understand your own thought processes.
Okay. So let's unpack this. The central idea, at least from what we see here, is this distinction between two systems of thinking. So we've got system one,
Right.
which is fast, intuitive, and emotional. And then we've got system two, which is slower, more deliberate, and logical. And what I think is so fascinating, at least from what I've read so far, is just how much of your, day-to-day life is governed by this automatic system one.
Yeah, it's amazing, really. It's just operating in the background constantly. When you effortlessly understand a simple sentence, when you see a friend's face and you recognize them instantly, or when you react with disgust to something unpleasant, these are all happening in a split second, no conscious effort.
Right.
You don't decide to understand the words you're hearing. It just happens.
Right.
And that's system one, just doing its thing.
Right.
And the key is that your brain is constantly making these quick judgments and associations, and you're not even aware of it.
Right. And then system two steps in when you encounter something that's a bit more demanding, I guess.
Right.
Like if I asked you to calculate 17 multiplied by 24 in your head,
Oh, God.
you'd have to really focus.
Yeah.
That's system two. That's system two taking over. It's that, effortful calculation. Or if a lamp suddenly jumped across the room,
Right.
that'd be so strange.
Yeah.
Or a trigger system two would be like, whoa, what just happened?
It's that mental, hold on a second.
Yeah.
What's going on here?
Totally. So system two gets involved when things get a little complex or when they violate your expectations, I guess.
Yeah. And if we zoom out a little bit, this idea of a cognitive budget
Right.
is a great way to understand why system two needs energy.
Yes.
It's not unlimited, and when system two is busy tackling, a demanding task, it doesn't have as much energy left over for other things.
Right.
So, that experiment where people are asked to solve a tough math problem while walking, and then they just stop walking.
Right.
That shows you just how limited that capacity can be.
Totally.
Oh, it really is like your mental battery just
Right.
drains when you're really concentrating.
Totally, yeah. And this connects to Baumeister's research on ego depletion,
Yeah.
which we have in the sources here. And I think it's so surprising, like the idea that if you use self-control in one area,
Right.
it can make it harder to exert self-control in a totally different area later.
Yeah. It's almost like a muscle,
Yeah.
It gets tired.
Yeah. It's like willpower is a finite resource.
Yeah.
And that, that famous radish and cookie experiment, have you heard of that?
Yeah, yeah.
Where people who had to resist eating those tempting cookies ended up giving up way faster on this really difficult puzzle.
Yeah.
So it really shows you that mental exertion in one task can just like drain your willpower for the next.
You use it up.
You use it up.
Yeah.
Yeah. So this brings up an important question about how efficient our thinking really is.
Yeah.
Like system one is super fast and it doesn't need much energy, but it relies on those intuitions and mental shortcuts.
Right.
Or heuristics.
Heuristics, yeah.
As Kahneman and Tversky call them. And I think it's really important to remember that these shortcuts, while they can be really helpful in everyday life, also come with these built-in tendencies to make mistakes.
To err, yeah.
To err, yeah.
Yeah.
And that's where those biases come in.
Exactly. It's like a trade-off, between speed and accuracy.
Yeah, absolutely. And the bat and ball puzzle is such a great example of this. So a bat and ball together cost $1.10.
Okay.
The bat costs $1 more than the ball. How much does the ball cost? What pops into your head right away?
10 cents.
Right. 10 cents. But that's actually not right.
Right. It's a trap.
It's a trap, right? And that's system one, just like going for that quick, seemingly obvious answer.
And it feels right.
And it feels right.
Yeah.
But the actual answer is 5 cents.
5 cents, yeah.
Right. Because if the ball is 5 cents, then the bat is $1.05. And that adds up to $1.10.
Right.
So the key takeaway here is to always, always double-check those quick answers. Because your brain loves to cut corners, but those corners can lead you astray.
Yeah, and the role of system 2 here is fascinating, right?
Yeah.
Because if you quickly said 10 cents, you probably didn't even engage system 2,
Right.
to actually check that intuition.
Yeah.
And it would have only taken, maybe 5 seconds
Right.
of mental effort to realize that, wait a minute, if the ball costs 10 cents, then the bat would cost $1.10.
Right.
That doesn't add up.
Yeah.
But so many people miss that simple check.
Yeah.
Because, our minds are following this law of least effort.
Amazing.
They want to conserve energy whenever possible.
Like our brains are lazy.
They are.
Yeah.
They like to conserve energy.
So let's talk about this idea of associative activation, because this is like getting into how our brains connect ideas.
Right. How it all links together.
Yeah.
Yeah. So you've got this concept where one idea, even a single word, can trigger this cascade of related thoughts, emotions, memories, even physical sensations.
Right.
And the example in the book that uses vomiting and reliable, that shows you how powerful this can be. You hear those words together and there's this instant reaction because they don't typically go together.
Right.
And so your brain is trying to make sense of that, trying to build a story, even if it's a bit strange.
Right.
And the key here is the coherence of those associations, right?
Right.
Vomiting brings to mind, feelings of illness, unpleasantness, and then pairing that with reliable, it just creates this sense of surprise.
Yeah.
It shows how your brain's always trying to make things fit together, even when they seem unexpected.
Right. And then we get to priming, which is where things get really, really interesting.
Yeah.
And the elderly words experiment.
Yeah.
Where the students, they were just, exposed to words related to old age.
Right. Subtly,
right. And then they actually walk slower down the hallway afterwards.
Yeah, it's wild, isn't it?
That's so strange.
These unconscious cues, they can actually affect your actions without you even knowing it.
Right.
And the Lady Macbeth effect, that kind of subconscious urge to cleanse yourself after feeling guilty, that's another example. It shows you how even abstract moral concepts can actually influence your behavior.
So it's like our morality is like tied into our physical actions.
It's all connected, yeah.
Yeah, that's so wild. I can see why people react to these priming studies with like disbelief.
Right.
Yeah,
absolutely. It's challenging that feeling of being in control,
Right.
of your own thoughts and actions.
But the text says that, while these priming effects are definitely real and measurable, they're not massive in their impact.
Right. Yeah.
It's more about nudging behavior, I guess.
Nudging,
than completely controlling it.
Yeah.
But even small changes in behavior, right?
Yeah.
Can make a big difference.
Absolutely. Especially in things like marketing and political campaigns,
Oh, yeah.
where even a small shift in opinion can have big consequences.
Okay. Now let's get into cognitive ease.
Right.
Because I think this is really important.
Yeah. So when information is easy for your brain to process, because it's familiar or it's clear or it's been repeated, you get this feeling of cognitive ease. And that feeling can trick you into thinking that something is true or correct, whether it actually is or not.
Right.
So just because something feels easy to understand doesn't mean it's accurate.
Yeah, that's such a good point. And that experiment, that one with the music in the earphones, do you remember that one?
Oh, yeah.
So clever.
Yeah, really insightful.
So they gave people this alternative explanation for why they were feeling good, which was the music they were listening to.
Right.
And then suddenly that feeling of coherence with the word puzzles they were solving, it just disappeared.
Yeah, which showed that it was the ease of processing that was driving that sense of, things making sense.
Right.
Even though the music had nothing to do with the puzzles.
Right.
It was just creating a feeling.
Right.
A feeling of cognitive ease.
Okay, and then how about this idea of how familiarity reduces surprise? Like that story about running into the same acquaintance, John.
Right, John.
And all these increasingly unlikely locations.
Yeah. It's a great example. The first meeting was a surprise, but then the more you see him in these odd places, the less surprising it becomes.
Right.
Because your system 1 has created a new category for meeting John in strange places.
Right.
So the improbable starts to feel almost normal.
It's like our brains adapt, right?
Adapt quickly.
To new patterns.
Yeah, even if those patterns are weird. Yeah. Like, okay, this is a thing now.
Meeting John in weird places, it's a thing now. All right. But our brains are also super quick to detect abnormalities, like even very subtle ones. You know the example of the word cement appearing in that sentence
Yeah.
about the earth revolving around trouble?
Yeah, it just jumps out at you.
Right. You're like,
So-
what? That's not right.
And what's amazing is that your brain flags that incongruity instantly,
Yeah.
even if you're not consciously paying attention to it.
Right.
And the studies that show, these brain responses happening within a fraction of a second,
Right.
it's just astonishing how fast it all works.
It's like there's a silent editor in our minds, constantly checking for mistakes.
It's like a spell checker, but for reality.
Yeah, exactly.
Making sure everything makes sense.
Now, this extends to our perception of causality.
Right. Cause and effect.
Yeah. So Michaud's experiments with the moving squares, have you seen those?
Yeah.
Where you see one square hitting another and causing it to move,
Right.
even though there's no physical connection.
Yeah.
It's all an illusion, but it feels so real.
It does. It feels like one square is making the other one move. But it's just your system one creating that story.
Right.
And the fact that even infants show this tendency to perceive cause and effect,
Right.
it suggests that this isn't just something we learn from experience.
Well,
it's more like it's built in, you know?
Yeah, like we're wired to see the world in terms of actions and consequences.
Exactly. We're looking for those connections all the time.
Yeah. Which brings us to the inherent gullibility of System 1.
Oh, yeah.
And this concept of what you see is all there is. W-Y-S-A-I-D.
WISAD.
Because System 1 is all about building a coherent story from the information that's immediately available.
Right.
Doesn't really stop to think about what might be missing. And while System 2 can step in and be like, hold on, let's think about this.
Yeah.
It's not always active or diligent.
You could be lazy.
Yeah, it can be lazy. So your initial understanding of a situation
Right.
might be based on incomplete information.
Right.
And you might not even realize it.
Yeah, and when System 2 is busy with other things or just taking a break, you're much more likely to just accept whatever story System 1 has cooked up,
Right.
even if it's based on a limited set of facts.
Right.
This explains why, you're more susceptible to those persuasive messages, like in advertising.
Oh, yeah.
When you're tired
Right.
or distracted.
Yeah.
Your inner skeptic, he's off duty.
He's taking a nap.
He's taking a nap.
Yeah.
Yeah.
Okay, so we've got this reliance on WYSIA and this tendency to substitute a hard question for an easier one. And I think that really sets the stage for a whole bunch of biases. So let's start with overconfidence, because this is a big one.
Yeah.
Your confidence in your beliefs is often based more on the quality of the story you can construct to support them
Right.
than on the actual evidence. So just because you feel really confident about something doesn't mean you're actually right.
Yeah, because System 1 loves coherence.
Right.
So a good story, even if it's based on, shaky foundations, can make you feel really sure of yourself.
Totally. Yeah.
But you might be missing key information.
Right.
And your System 1 doesn't care. It's like, hey, this story makes sense. We're good.
We're good.
Yeah.
All right. And this ties into framing effects, which is just wild to me.
Oh, framing.
Yeah.
It's so powerful.
So the way information is presented can totally change your emotional response and your choices, even if the facts are exactly the same.
Yeah, it's like the classic example. If
Yeah.
you tell someone that a surgery has a 90% survival rate,
Right.
that sounds pretty good, right?
Yeah.
But if you tell them that it has a 10% mortality rate, suddenly it feels a lot riskier.
Yeah.
Even though it's the same thing.
It's the same thing.
It's just framed differently.
Same thing. Yeah.
Yeah.
And it works with everything,
Yeah.
Like ground beef, if you say it's 90% lean,
Right.
it sounds way better than 10% fat, even though it's the same beef.
It's the same beef.
Your System 1 reacts to the emotional tone of the message,
Yeah.
not the actual facts. Yeah, totally. And then we have base rate neglect.
Yeah.
The Steve the Librarian example, right?
Oh, yeah.
It's perfect for this.
Yeah.
So you've got these vivid descriptions
Right.
that can just completely overshadow the actual probability.
Yeah, like even if you know logically
Right.
that there are more male farmers than male librarians, if you hear a description of Steve that sounds like a librarian, you're going to ignore the statistics.
Right.
You're going to go with your gut feeling.
With your gut.
Yeah.
Yeah. So a good story
Right.
can be way more persuasive
Absolutely.
than cold, hard facts.
It's more compelling,
Yeah.
It's easier to grasp.
Totally. And I think it's fascinating that our System 1, like, it registers averages.
Yeah.
Like the length of lines, for example.
Right.
And it can easily handle small quantities, like if I showed you 4 objects.
Yeah.
But when it comes to, like, more complex statistical reasoning,
Yeah.
we really need System 2 to get involved.
System two's got to put in the work.
It's got to put in the work.
Yeah.
And that brings us to substitution in a more formal sense, I guess.
Right. So when you're faced with a tough question, something that really requires deep thinking,
Right.
your System 1 tries to cheat.
Right.
It substitutes that hard question with an easier one.
Right.
You answer the easier question, and without even realizing it, you think you've answered the original one.
Right. And that visual illusion with the sizes of the figures in the drawing compared to the heights of the people,
Oh, yeah.
that's a perfect example of this.
Mm-hmm.
Because you know you're supposed to judge the 2D size of those figures on the page.
Right.
But your brain automatically sees it in 3D.
Yeah.
So you end up answering the question, how tall are these people?
Right.
Instead of, what's the actual size of the figures?
It's a classic substitution.
The classic substitution, yeah.
Yeah.
And it's so automatic, you can't really help it.
You can't fight it.
Can't fight it.
Your brain is trying to help, but it's not always helpful.
Yeah, sometimes it backfires. Okay, let's talk about the law of small numbers, because I think this is really important.
Yeah.
So this is our tendency to see patterns
Right.
and causal explanations in totally random events, especially when we're dealing with small samples of data.
Yeah.
And the example of the kidney cancer rates in those rural counties is just like so striking.
Yeah, because people see those higher rates in those less populated areas and they immediately jump to conclusions.
Right.
Oh, there must be something environmental going on there.
There must be something in the water.
Something in the water.
Yeah.
But statistically speaking, smaller samples are just more likely to have extreme values,
Right.
high or low.
Right.
It's just random chance.
It's just random.
Yeah.
It's an artifact, right,
An artifact.
of the research method. So you got to be really careful about drawing big conclusions from small amounts of data.
Yeah, and even Kahneman himself admitted to making this mistake,
Right.
Early in his career, he realized he was drawing conclusions from studies that just didn't have enough participants.
Right.
It's easy to do,
Yeah,
especially when you're excited about your research.
totally. Yeah. And then you've got the hot hand fallacy,
Oh, yeah.
which is so interesting because it's like everyone believes in it.
It's such a strong belief.
Yeah.
Yeah, like if a basketball player makes a few shots in a row,
Right.
you just assume they're on fire.
They're on a fire.
You can't miss.
Yeah.
But statistically,
Right.
there's no evidence for it.
No evidence.
Yeah, it's just random chance.
Yeah. And this shows like our deep desire as humans
Right.
to find these patterns
Yeah,
in randomness. It feels right,
it does.
but it's not actually supported by the data.
Our brains are pattern-seeking machines,
Yeah, they are.
even when there's no pattern to be found.
Okay, so anchoring, this is where it gets a little weird again.
Anchoring.
Yeah.
Yeah, so this is when a totally random number can actually influence your estimates,
Right.
even when you know that number is irrelevant.
Right. Like the example with the Wheel of Fortune.
Right.
And the number of African countries in the UN.
Yeah, totally arbitrary number.
Totally arbitrary.
But it still affects people's guesses.
Yeah.
It's like this invisible force
Right.
pulling your judgment in a particular direction.
Yeah. It's so strange. And the text suggests that it might be because of, what do they call it? Insufficient adjustment.
Insufficient
So
adjustment.
you get anchored to that number,
Right.
and then you don't move far enough away from it when you're making your estimate.
Right. You're stuck in that range.
You're stuck.
Yeah.
Yeah.
And what's interesting is that this happens even with professionals,
Right.
like the real estate agents in that experiment.
Right.
They swore up and down that the initial asking price didn't affect their valuation, but
It did.
it did.
Yeah.
And they wouldn't even admit it.
It's like they weren't even aware of it.
Totally unconscious.
Yeah. It's so crazy how much of our thinking is unconscious.
Most of it, probably.
Probably. Yeah.
Yeah.
But the good news is that there are things you can do to resist anchoring,
Right.
like actively thinking about arguments against the anchor.
Yeah, I think the opposite.
I think the opposite, right?
Yeah.
That can help to counteract the bias.
It forces you to engage system 2.
Okay, so let's talk about the availability heuristic.
Oh, right.
So this is where you judge the probability of something happening based on how easily you can think of examples.
Right. If you can easily recall instances of something,
Right.
you assume it must be more common.
Right.
It's like your brain using Google search results,
Right, right.
The more results, the more common it must be.
Yeah, and that experiment by Schwartz where he asked people to recall either 6 or 12 instances of their own assertiveness.
Yeah, that was a good one.
So counterintuitive.
Yeah.
The people who had to come up with 12 examples rated themselves as less assertive.
Yeah, because it was harder for them.
It was harder.
Yeah. And they
Oh.
thought, well, if it's so hard to come up with examples, I must not be that assertive.
Right.
Even though logically it should be the other way around.
Right.
The more examples you can recall, the more assertive you should be.
Right.
But it's not about the number of examples.
It's about the ease.
It's about how easy it is to come up with them.
Yeah.
Yeah.
Yeah, and this can really distort our perception of risk, too.
Absolutely. Think about things like, plane crashes or shark attacks.
Right.
They're so vivid, so memorable, so they feel much more common than they actually are.
Right. And they get so much media attention.
Exactly.
Yeah.
The media loves those dramatic stories.
Right.
So they're constantly in our minds, even though statistically they're
Right.
incredibly rare.
Right.
And then we worry about them way more than we should.
Yeah, and we neglect those more mundane risks, right?
Yeah, the everyday stuff.
Yeah.
Car accidents, heart disease, those things are actually much more likely to kill us,
Right.
but they don't make the headlines.
Yeah.
So we don't think about them as much.
Okay, and then we have representativeness.
Right.
So this is another shortcut where you judge the probability of something belonging to a category
Yeah.
based on how similar it is to your mental prototype of that category.
Yeah, it's like stereotyping, but for probabilities.
Right.
You see something and you think, oh, this looks like a duck, so it must be a duck.
Right, and the Tom W. example is perfect for this.
Yeah, the description of Tom
Right.
fits the stereotype of a librarian so well that people ignore the base rates.
Right.
The fact that there are way more engineers out there,
Right.
they just focus on how well Tom matches their image of a librarian.
And this can lead to all sorts of logical fallacies like the Linda the bank teller problem.
Yeah, where people think it's more likely that Linda is a feminist bank teller than just a bank teller, because the description makes her seem like a feminist.
Yeah, and it feels more coherent.
More coherent.
Yeah.
But it violates the rules of probability.
Right.
The more specific something is, the less likely it is to be true.
Right.
But our brains don't always follow the rules.
Yeah. And it's so interesting that when they presented this problem
Yeah.
in a frequency format,
Right.
like how many people out of 100 fit this description,
Yeah.
suddenly people were much better at reasoning statistically.
It's easier to grasp,
It's easier to grasp.
when you're thinking about concrete numbers of people
Right,
than
right.
abstract probabilities.
Yeah. So our brains are better at dealing with frequencies
Yeah.
than with percentages.
It's more intuitive,
It's more intuitive.
Yeah.
Okay. And this distinction between causal base rates and statistical base rates.